Hi guys, I just wanted to get on today and go over some notes. Let's see. Oh, there's me. So today we are going to be picking up our notes from yesterday. I realized after I finished the video yesterday that I left off part of that. So if you printed off the notes from yesterday, we didn't make it to this little statement that's on the screen right now. Effective adaptations are reproduced in nature as a result of natural selection. And we didn't make it to the Venn diagram. So we're going to add those onto our notes to today, in addition to the ones that are attached to the assignment for today's notes. And so Charles Darwin, we were talking about yesterday how he came up with this idea of natural selection after studying several different places in nature. And he noticed that those effective adaptations, those adaptations that allow organisms to be more fit, are reproduced because those organisms survive and are able to have offspring. Those offspring then have those same characteristics. So that effective adaptation is a result of natural selection. Sorry, I have to look up at the board every time to see where my face is. Okay, so if we look at these three giraffes, you can see that there is a short giraffe, a medium giraffe, and a tall giraffe, right? This giraffe here on the end, he's short. Is he going to be able to reach these leaves in the tree? Probably not, right? Sorry, I'm trying to make this so it's better. If you're this little guy, you're not going to be able to reach up tall. You're only going to be able to eat leaves that are down low. So is that going to be the best chances of survival for you? Maybe not. If we look at our guy in the middle, he can reach a little bit higher than our first guy we talked about. But is he going to be able to reach those tall branches? Maybe not. So he's not going to have as much of an opportunity to eat. And so giraffes, over time, the longer the neck, the more able they were to survive. And so longer-necked giraffes became more and more common because long-necked giraffes were able to reproduce and have babies. They passed on their long-neck genes to their babies, which then bred with other long-necked giraffes and made more longer-necked giraffe babies. So over time, those characteristics became an adaptation because they were able to survive in their environment better with that quality than with a different one. The same thing is true for mice of different colors. Some mice are eaten by the birds, right? We look at the first picture. We've got 6 tan mice and 3 gray mice. And so the bird is going to be more able to see the lighter colored mice against a dark background. The ones that are left are going to be the only ones that are going to be able to reproduce. So those 3 gray mice are going to reproduce and make more and more gray babies. The 2 tan mice maybe get eaten. Maybe some of their offspring get eaten. Maybe they're struggling to survive more, so they're not able to reproduce as much. So they're not going to be able to have as many babies. They're not going to be able to carry on their genes as well as the gray mice. Does that make sense? So if we look at that Venn diagram on your notes that you printed off yesterday, and we're going to sort these for you guys to put in each of the bubbles. So if we look in the middle, natural selection versus selective breeding, which of these boxes is going to fit in the middle of the best? Controlled by humans, offspring inherit traits, survival of the fittest, produces offspring with desired traits, produces offspring with traits that help it survive, or it's controlled by nature. The thing that's going to fit most appropriately in the middle is that offspring are going to inherit traits. So that's going to go in the middle between the two. With both selective breeding and natural selection, offspring are going to inherit traits from their parents. Now, when we look at survival of the fittest, what does that make us think? Is it going to make us think natural selection or selective breeding? I hope you said survival of the fittest makes you think natural selection, because that's another way that we discuss and talk about and put a name to natural selection. What about produces offspring with desired traits? Which one, natural selection or selective breeding, is going to produce offspring with traits that we want? That's going to be selective breeding, right? We're choosing the traits that are going to carry on from one generation to the next. Which bubble is going to have offspring that has traits that help it to survive? Help it survive. Remember, survival of the fittest. Anytime we're talking about survival, we're talking about natural selection, because natural selection allows nature to choose who survives and who doesn't. Which one of these are controlled by nature? Well, I just gave you the answer to that one. Natural selection is controlled by nature, which means that selective breeding, just as a reminder, is controlled by humans. Okay? All right, so you can pause for a second if you need to get your other notes out, the ones that I put in there. And if you weren't able to print them, that's fine. You're just going to fill them in just like you would writing in your journal, right? It just makes it a little less writing that you have to do if you're able to print out the notes. So we're going to be focused on mostly adaptations today. And adaptations, remember, are things that help an organism to survive in their environment, because if it's able to survive, it's going to be able to reproduce. Sorry, I'm still trying to get my coffee in. So we're going to be talking about three major types of adaptations. We're going to be talking about structural adaptations, behavioral adaptations, and physiological adaptations. So let's spend a second just to talk about each one of these. Structural adaptations are a physical part. This is going to be a part of their body or structure that helps that organism to survive. Okay? It's a physical feature. It's a physical part of their body. It's something that you can see, touch, feel. Okay? Behavioral adaptations are actions, things that an organism does on purpose to be able to help it to survive, right? These are choices. And then a physiological adaptation is involuntary, but it's still an action. It's an action that's a reflex or an automatic response, like sweating. That's a physiological response that helps us survive in our environment, right? What would be a structural adaptation that helps a porcupine survive? It's quills, right? A behavioral adaptation that allows a school of fish to survive is going to be schooling and staying together, right? Behavior, they travel in schools. So each one of those types of adaptations are important for different organisms to be able to allow them to survive. Can you tell the difference between the three types? So let's give you a little mini quiz. Ooh, I guess I need to move my face. I'm going to just move my face off of here so you guys can see, because there's lots of pictures today. Okay. So is it structural, behavioral, or physiological? Okay. If we've got a school of fish that swim in schools, this is going to help protect them. What kind of adaptation is that going to be? I literally just gave that to you as an example. What about a bird call that attracts a mate? Can you guys hear the bird calls? Different bird calls from different types of birds. What type of adaptation is that? And squirrels burying resources of food for winter. What type of adaptation is that? So is that going to be structural, behavioral, or physiological? I hope that you said behavioral. Behavioral adaptations are things that organisms do. And swimming in schools, burying food for winter, calling or howling or crying, those are all things that an organism does. So we're going to put this little table in our notes, and we're going to have structural adaptations, behavioral adaptations, and physiological adaptations. So let's fill in some examples, right? You can put the ones that we just talked about. You can put the ones that are on the screen. I just want you to have 3 behavioral adaptations. So the ones that I listed here for you are fish swimming in schools, right? Swimming together. Plants growing towards the sun. And we're going to talk more specifically about plant-specific adaptations in a few days. Birds flying south for winter. Hibernating bears is also a behavioral adaptation. Snakes, when they coil and strike, those are behavioral adaptations that help them to survive in their environment. So you're just going to write 3 behavioral adaptations in that little chart on your notebook. And remember, structures are parts, behaviors are choices, and physiological adaptations are automatic responses or reflexes. Okay, let's look at these. So we're again going back. Is this structural, behavioral, or physiological? So quills on a porcupine. Is that going to be structural, behavioral, or physiological? A prehensile tail, a tail that helps a monkey climb. See how it's supporting his weight up here at the top and helping him climb. What type of adaptation is that going to be? And then white fur on an Arctic fox. or camouflage? What type of adaptation is this going to be? Is it going to be behavioral, structural, or physiological? Quills, fur, and tail. Those are all body parts or structures. So those are all structural adaptations. We're going to fill in our same little table, right? You should have those two columns filled in. Duck's webbed feet, leaves on plants absorbing sunlight, a snake's hinged jaw. You can put porcupine quills. You can put white fur. All of these are examples of structural adaptations. My light just turned off. Okay, so all of these are helping an organism to survive, and if it survives, it can reproduce. Okay, these are body parts, right? Structures. Now, when animals shed their winter coat, right, to stay cooler in hot weather. When organisms sweat to stay cool. When organisms have a fight or flight response, right, using adrenaline. Remember, we talked about that when we talked about the endocrine system, right? Your heart speeds up, not just when you're in a haunted house, but animals do this too, right? That's why bunnies run away when they get startled, or deer gallop away when they get scared. Fight or flight. Your pupils get dilated or bigger or darker, bigger when they're in dark places to let more light in, or smaller when you're in bright places to decrease the amount of light. All of those are what type of adaptation? They're an automatic response. They're not controlled by you. They are physiological, right? So in our table, we should have those first two columns filled in, and then you can add in some of those things we just talked about: shivering or sweating when you're hot or cold, a wolf growing a thicker coat in the winter, cat's fur standing on end when they're threatened or scared, a deer running away when they're startled. All of those things are physiological adaptations that help an organism be able to survive in their environment. And remember, structural adaptations are physical parts, behavioral adaptations are choices that we control, and physiological adaptations are things that happen out of our control, that our body does automatically. So let's talk specifically about some structural adaptations that can help organisms be able to survive in their environment. Structural adaptations can be internal, meaning they're inside the organism, like gills in fish or hollow bones in birds. Now, fish gills help them to be able to breathe underwater. And that's very important for fish because they still need to go through cellular respiration. When we have hollow bones in birds, you can see in the diagram how thick and compact our bone is. Remember, we talked about those different types of bones that we have. And even our spongy bone is nowhere near as hollow as bird bones. And bird bones are light because they need to be able to fly. And the lighter they are, the more able they are to fly wherever they need to go. Structural adaptations can also be external, meaning they're outside the organism. That means that they are things that we can see, right? Hooves are a way that horses, goats are able to move and support their really heavy bodies with some really tough material on the bottom because their bodies are so thick and strong and heavy, and so they need that strong platform for their bodies. Webbed feet allow ducks and frogs be able to swim. Beak styles we talked about a little bit yesterday, and there's lots more different beak styles from lots of different species of birds that allow them to eat different types of foods in their environment. Long necks for giraffes not only help them reach tall trees, but they also use it as a fighting tool to be able to fight, to be the strongest male, to be able to mate with the female giraffes. All of those are structures that are outside. Now, some structural adaptations are pretty cool. They are camouflages, and some organisms are able to use color to blend in their surroundings that they control, and they can change their color. Some just happen to have coloring that helps them blend into their surroundings. These are two different types of camouflage, but they are both under the same category of blending into your surroundings to be able to hide from predators. Mimicry is when an organism looks or sounds like another living organism. For example, there are two types of butterflies we're going to talk about: the viceroy butterfly and the monarch. One of these is the monarch, and one of these is the viceroy. Now, the monarch, it has what we call warning coloring. It's orange because it tastes really bad to birds, and it warns them, hey, don't eat me because I'm not a good tasty snack. The viceroy is a tasty snack for birds, and so they look similar to monarchs as a mimicry to help protect them. And this happened because over time, natural selection, viceroy butterflies that looked more like monarchs were not eaten as often, and so they reproduced and had babies that also looked more like monarchs. And so it's hard to tell the difference between those two different types. Some other types of mimicry are the hawk moth caterpillar. It actually looks like a snake head. It's a caterpillar. It's this one in the top left-hand corner, right? It looks like a snake, but it's not. You can see that its body is just really short, and it has this kind of pointed head that gives predators the idea that it is a snake, and so it scares them away. When you look over here on the right side, octopus are kings of mimicry because they can really change a lot of how their appearance looks because of some special pigments and receptors in their skin. And so the sea snake is a very poisonous snake. Some would say one of the most poisonous snakes on Earth. And so the octopus kind of hides in a hole and makes his tentacles look like an octopus. Look like a sea snake. Now, both of these organisms that you see in the pictures on the screen use biochemicals like venom, ink, and sprays to help defend themselves from predators, and they also help them to capture prey. These are the octopus using ink helps it escape from predator. Venom would be the type of biochemical that would help capture prey from maybe a snake or a spider. Skunks, we know around here, are very stinky and can scare and ward off predators to help them be able to stay alive, because if they're alive, they can reproduce. Certain body coverings also serve to protect organisms and help them survive so that they can reproduce. Body coverings like armor plates on a turtle. You can see in the little GIF there that the alligator's trying to eat the turtle, but his shell is so hard and difficult to manage that the alligator's having a hard time even getting it in his mouth. So it's protective like that. You know that elephants have these long tusks and a trunk, and the tusks help them to be able to battle with other elephants, and the trunk helps it to pick up things, get food, clean itself. It serves a lot of different purposes, and these are body parts that help these organisms be able to survive. Now we're going to talk a little bit about those behavioral adaptations. These, remember, are things that allow an animal to respond or make a choice. Animals being able to respond to the needs of their life, these are actions. They can be learned traits, or they can be instincts, things that they're born with. And so we're going to talk about both of those. Some examples of some learned behavioral adaptations are when capuchin monkeys teach younger monkeys to use tools. They use rocks to crack open nuts to be able to get to the inside and eat the sweet nut that's inside the hard outer coating. And so these are skills that are taught by their parents or other members of their living group. And so they are a learned behavior, right? Instinctual behaviors are things that animals just know how to do. Nobody teaches them, they just do it. In fact, scientists are trying to figure out how they even know how to do it, especially long migrations from organisms like sea turtles and whales. They're able to retrace steps to their birthplaces, and we don't know how they do that. These are just skills that are known from birth that nobody teaches them. It's just a behavioral adaptation, something that they do that helps them to survive. Some more examples of these behavioral adaptations are things like mating rituals, like we saw the video of the giraffes fighting, dancing. Certain birds do dances to attract a mate. All of those are different rituals and things that organisms do to help attract a mate to be able to reproduce. Hibernation, of course, allows an organism to survive through cold winters when food is scarce. and so they go into kind of a deep sleep and don't really move around a lot or use very much energy, so that the energy fat that they've stored will help get them through to survive until the next eating season. Storing food, organisms like squirrels and chipmunks are hoarders of food, and so they are able to stock up so that they can survive through cold seasons. Also, a way that organisms live, whether they live alone or in packs, herds, colonies, bees live in hives, all of those are behavioral adaptations that help them to survive, right? Hives are strength in numbers and allows certain worker bees to go get nectar to make honey, and some are those little caretaker bees that take care of the larvae and make sure that they're fed. Everybody has a job in these colonies or hives, and it helps them to survive. Physiological adaptations are adaptations that happen automatically. They're an automatic response that can change based on an animal's environment, right? So a puffer fish swells up with water to be able to make itself look big and menacing, even though it's very small fish, actually. Quills, obviously, we talked about as a structural adaptation, but the movement of responding to someone touching those quills is a physiological adaptation. It's a reflex that porcupine has to be able to protect itself, to inflict some damage on whatever's trying to attack it so that it will leave it alone. Despite what people think, porcupines cannot shoot their quills, but they do flick their tail, which can kind of slap something in the face and inflict a lot of pain with those quills. Something to note, physiological adaptations are all because the body of the organism is trying to maintain equilibrium, that balance, that body balance, that homeostasis. And so physiological adaptations are adaptations that allow the organism to maintain the internal conditions, even if something's changing the outside, so that homeostasis can be maintained in the organism's body. A stimulus is a response. A stimulus is a change to an environment, right? Whether it's a change in weather or a change because there's something that flies in front of the bat's face, or whatever the change might be, the stimulus is that change. That's our fancy science word for a change in the environment. How an organism responds to that stimulus is its response, right? What it does in reaction to that change is its response. And so stimulus and response is kind of our fancy science way of saying cause and effect in nature. Physiological adaptations are a result of stimulus and response. Okay? Here's some examples. Rabbit gets scared, so it runs away. Physiological response, that's that fight or flight. You're feeling cold, so you put on a jacket, right? When you feel cold, you might also get chill bumps. That's a physiological response. A dog gets hot, so it moves to the shade, right? It's trying to cool itself off. We need to maintain body temperature so that we can go through our body's normal routines and stay in homeostasis. The dog is trying to restore homeostasis when it gets too hot. It starts raining, so you take out an umbrella. We want to maintain our comfort. When we get cold, when we get wet, we often get cold. When we get cold, we shiver, right? That's our body trying to maintain homeostasis, that body temperature. So here's a couple more examples. You can see here that the bunny is kind of running away from that predator bird and using their fight or flight response. Same with the snake, right? They're striking so that they can initiate that capture of prey and be able to take it over. I hope that helps you guys be able to see some examples of adaptations that different animals have. And next time we'll be talking about plant adaptations. Have a great day.